Hey guys, we're going to go over a Chapter 5 review, and on this one we're going to go ahead and go over, it's kind of like a free response type of question. So it says here, a statistics teacher has 40 students in his class, 23 females and 17 males. At the beginning of the class on Monday, the teacher planned to spend time reviewing an assignment due that day. So unknown to the teacher, only 19 of the females and 11 of the males had completed the assignment. The teacher plans to randomly select students to do problems from the assignment on a whiteboard. So it says here, what is the probability that a randomly selected student has completed the assignment? So what I recommend here is you guys make a two-way table. Okay, so if you guys remember a two-way table, you guys go ahead and list out what's going on in this example. So here we're going to go ahead and put females and males. And then I'm going to put C for completed and NC for not completed. And we know the total, it's going to be 40 students, okay? So we know we have 23 females in total and 17 males in total. We also know that 19 of the females and 11 of the males completed the assignment. So here we know that this is 19, because 19 females completed and 11 males completed. So when you add these up, you get 30. And then what's missing here is a 4. What's missing here to get to 17 is an 8. So when you add these up, I'm sorry, this is a 6, not an 8. And you get a 10 here, okay? So now you're going to be able to get the probability that the randomly selected student has completed the assignment. So the probability that a student's going to complete the assignment is 30 out of the 40, because that's how many students completed. So here we're going to get the probability that a randomly selected student completed the assignment, let's call it C, is equal to 30 over 40, which is also 0.75. Okay, so that's the probability for that one. Next one says, are the events selecting a female and selecting a student who completed the assignment independent? Justify your answer. So we want to see if the probability that completing an assignment, so I'm going to put here completed, given that you're a female, is the same as the probability of it being completed. Okay, so this is the formula to check to see if it's independent. So we already know, the reason I chose this one is because I already know the probability, but the other one I could have switched these up. Okay, so it doesn't really matter in this case. Alright, so now in order for us to figure this one out, we're limited to the females, right? So we're limited to this portion here. So out of the 23, how many completed? So it's 19 out of 23. So since these are not equal, that makes these not equal. That means that they're not independent. So what it's important to know is that since they're not independent, that means that we can tell if he chooses a female, then the chances of her completing it are higher than if you chose a male. So since that's why they're not independent. Okay? Alright, let's look at the next one. It says, suppose that the teacher randomly selected 4 students to do a problem on the whiteboard and only 2 of the students had completed the assignment. Describe how to use a table of random digits to estimate the probability that 2 or fewer of the 4 randomly selected students completed the assignment. Alright. So what we need to do first here is, since we're going to be using a table of digits, we're going to need to assign values to those students that did complete the assignment and those that didn't. So since we know it's 30 out of 40, I'm going to say those students that completed. So we're going to let completed assignments be the same as 0, 1 to 30. So that's 30 digits between those two. Okay? And the next one, we're also going to say, and we're going to put not completed. So those that did not complete be the same as 31 to 40. Now it's important that whenever it's a single digit, you have to attach the 0 in the front. Okay? Alright, so now that we assigned it, we also have to exclude some, because we're going to run into the 2-digit numbers that we don't want. So skip. So we're going to skip 0, 0 and 41 through 99 because we don't want to pick those. Those aren't part of the space that we want to use, okay? All right, so now that we have it assigned, now we're going to describe and give an example of one. So we're going to describe one example of how we're going to run through this, okay? So the first things we're going to do is we're going to start, so starting from left to right, we're going to go ahead and choose 4 different, it's important we say different, two-digit numbers, and then we're going to choose them from 0, 1 to 40. And that's because that's what we chose, right? And then once we choose 4 different of the two-digit numbers, we're going to count. We're going to count the number of students among the, so count the number of students among the 4 chosen who completed the assignment. Okay, so once we get our 4, we're going to see of the 4 we're going to see who of the 4 completed the assignment. Okay, all right, and then once we have that, that's the one example we're gonna have. Okay, so we have to describe the one example how it's gonna run, and then we need to let the reader know that we're gonna repeat many times. Okay, so we're gonna repeat it many times, and we're gonna divide the number of trials where 2 or fewer, so 2 or fewer completed the assignment by the number of trials. Okay, so that's it. So there's a couple things you guys need to know. You guys got to make sure you assign the numbers. You got to make sure that you make sense of the numbers, and you have to exclude any if you have to exclude. And then you're going to describe one example. So you're going to say, starting from left to right, we choose 4 different numbers. We choose 4 different two-digit numbers from 0, 1 to 40. And then we also have to explain how we're gonna determine how one trial is going to work. So it's going to be count the number of students among the 4 chosen who completed the assignment, and then we're going to do that many times, and then divide the number of trials where 2 or fewer completed the assignment by the number of trials. Okay, so here's the completed example. All right, so now the other question is asking, it says complete 3 repetitions of your simulation using the random digits below and the results to estimate the probability described in part C. Okay, so here we're going to go ahead and do 3 different trials. Okay, so let's do trial 1. Okay, so we're going to do exactly what it describes. So we're going to start here. So 1, 2, so that's going to be 1, right? The next one, 9, 7, we're going to skip that one. 5, 1, skip that one. 3, 2, we're going to keep that. 5, 8, nope. 1, 3, yes, so we have one more to choose from, and 0, 4. Okay, of these 4 numbers, how many were 30 or below? So we have 1, 2, 3. So 3 of 4. Okay, so 3 of the 4 completed. All right, now we're going to start again, but we're going to start from where we left off. So this is going to be trial 2. Okay, so it's going to be 8, 4, we're going to skip it. 5, 1, skip. 4, 4, skip. 72 skip, 32 we're going to keep, 18 we're going to keep, 19 we're going to keep, and 40 we're going to keep. So of those that all right, so now we have these 4 digits now. So 32, which means, remember, it means that you didn't complete the assignment. So we're trying to do trials in which they completed. So 32 means it completed. 18 they didn't complete, so that's 1. 19 they didn't complete. And then we also have 40. Okay, so that means only 2 of the 4 completed the assignment. Okay, so that's the second trial. The third trial, we're going to start from where we left off. So 0, 0 we're going to skip, 36 we're going to keep, 0, 0 we're going to skip, 24 we're going to keep, 28 we're going to keep, 96 we're going to skip, 76 skip, 73 skip, 59 skip, 64 skip, and then we have 23. So we have our 4 digits, okay? So of those 4, how many are 30 and below? So there's only 1, 2, 3. So 3 of the 4. Okay, so 3 of the 4 were completed assignments. So now if you kind of follow what we're saying, it says repeat many times, so I guess this counts as our many times. Divide the number of trials where 2 or fewer completed. So there's only 1 trial that was 2 or fewer by the number of trials. So we have 3 trials. So it's going to be 1/3. So 1/3 represents the probability that 2 or fewer completed the assignment. Okay.